Problem 1. A point moving with constant acceleration from A to B in a straight line AB has velocities u and v at A and B respectively. Now see, the problem has two parts. The first part is saying find the velocity at a point C where you are given that C is the midpoint of A and B. And in the second part we have to find the ratio v by u, and it is given that the time taken by the particle to go from A to C is twice the time to go from C to B. Okay. So let's see. As the first step, what I will do, I will present the information of the problem by a figure. So it is given that particle is going from A to B, correct? So let me label the 2 points. Say this is A and this is B. And C is given to be the midpoint of A and B. And the velocities at A and B are given as u and v respectively. Okay, so say here the velocity is u, here the velocity is v. We don't know the velocity at the midpoint C. And also we are not given what is the constant acceleration. It is given that it is moving with constant acceleration. So say let the constant acceleration be a and the velocity at C be vc. So basically we have to find this vc. Okay, and it is also given that C is the midpoint. So if I am taking the total length as 2l, so since C is the midpoint, so both these length segment will be same, each being equal to L, correct? We can apply, since A is constant, we are in a state to apply the equation of motion, and basically see we have to get the value of Vc in terms of u and v, correct? In the final answer we can't involve A and L because A and L are assumption in the working. The final answer must be in terms of the parameters provided in the problem. So if you apply the equation v square is equal to u square plus 2as, that is one of the equation of motion. And if you are applying this equation in both the segments, then I get the relation between u and vc and the relation between vc and v, correct? So if I am applying this equation between A to C, so in the segment A to C, the initial speed is u, the acceleration is a, the displacement is L. I am taking this side as positive axis, and it's a 1D motion, so no need to put the vector sign. And the final velocity is vc. So if I am applying this equation, I will get vc square is u square plus twice of al, correct? Let it be equation number 1. So this is the relation you got between vc and u when from A to C, correct? Now when you are applying this equation from C to B, so in this segment, what do you think? What is the initial velocity? So the initial velocity for this segment is the velocity at C, that is vc. The final velocity would be the velocity at B, that is v. The acceleration is same a. The displacement is again L. So this with the value final v square is vc square plus 2al, correct? So let it be equation number 2. So we got two equations in terms of v, u, vc and al. Now is simple mathematical working, no kinematics. The kinematics is completed here only. Now we have simple mathematical steps. Since we have to eliminate 2al, correct? Because 2al can't be answer. So what you can do, you can subtract equation number 2 from equation number 1, correct? You can subtract equation number 2 from equation number 1. So 1 minus 2 will give you vc square minus v square, and RHS will be u square minus vc square, correct? The factor 2al will get cancelled away to equations. So you will get what? Twice of vc square is u square plus v square. So therefore the value of vc will come to be what? U square plus v square by 2 under root. So you got the velocity of the midpoint. What will be the velocity of the particle at the midpoint, correct? That is u square plus v square by root 2. And this is the answer to part A. Okay, that is the answer to part A of the problem. Okay, part B is find the ratio v by u if the time taken from A to C is twice the time to go from C to B. Okay. Second part, which is saying we have to find the ratio Just duplicating this figure here. So we have to find the ratio. The second part involves the determination of the ratio V by U, and it is given that the time to go from A to C is the time to go from C to A. So we have to find V by U, and it is given that the time to go from A to C is twice the time to go from C to B. It is given, okay? So what we can do for part B, if this time is, say I'm taking as T0 interval, so this time will be what? According to the problem, this will be twice of T0, correct? Because the time to go from A to C is twice the time to go from C to B. So if this time is T0, this will be twice of T0. Now if I'm applying the equation of motion, V is equal to U plus A into time interval, say delta T, the time interval, from A to C. So the final velocity is Vc, the initial velocity is U, the acceleration is A, and the time interval is 2t0, okay? Let it be equation number 1. And if I am applying the same equation from C to B, so your final velocity is what? V, the initial velocity is what? Vc, plus the acceleration is A, and the time is t0. Got it? Now if you see both the you can eliminate A T0. So we'll have the relation between U, V and Vc. So if I'm eliminating T0, so what you will get? I can multiply equation number 2 with a factor of 2. So equation number 2, if multiplied by 2, it will become what? 2V is equal to 2Vc plus 2A T0. Let it be equation number 3. Okay, now both equation 1 and 3 has the same coefficient of T0, 2A. So we can cancel it because a final answer will not involve this term. So I can subtract equation number 3 from equation number 1. So I'll get Vc minus 2V, correct, is equal to what? U minus twice of Vc. So what you will get 3 times of Vc as what? U plus 2V. So you will get Vc as what? U plus 2V divided by 3. Let it be equation number 4. So this is another value of Vc you are getting in terms of U and V. Okay, the speed of the midpoint is coming to be U plus 2V by 3. In the presence of the information that time taken from A to C is twice the time taken from C to B. In that case, Vc is coming as this value. And in a generalized case, the constant acceleration, you have Vc is coming what? Under root U square plus V square by 2. Now in the second case, the cases because the particle is moving with constant acceleration, and this condition is also imposed. So from part A, you can write Vc as what? U square plus V square by 2. Because this condition is a generalized case when the particle is moving with constant acceleration. So this is the velocity at, and along with this condition, second condition is also met. So we can equate, we can put this value of Vc. So you will get what? U square plus V square by 2, that is the value of Vc from part A. And with the condition of time, you are getting the value of Vc as this. So both the sides, so you will get U square plus V square by 2 as what? U plus 2V whole square, and 3 square will be 9. So you will get U square plus V square by 2 as what? U square plus 4V square plus 4UV divided by 9, correct? You can cross multiply. So you will get 9U square plus 9V square is 2U square plus 8V square plus 8UV. So you will get 7U square plus V square, okay, minus 8UV is equal to 0. So this is the equation you are getting in terms of U and V. Now we need not to find values of u and v, we have to find a ratio, correct? We have to find the ratio v by u. So let v by u is equal to k. Let this ratio be k. I need to find ratio. What I can do, I can divide the whole equation by u square. So dividing by u square, I will get what? 7u square by u square plus v square by u square minus 8uv by u square, and of course 0 divided by u square will be 0. U square by u square will be 7, it will be 1, plus v by u whole square minus 8, and you will get what? V by u is equal to 0, and v by u we have given the name k, so we'll get 7 plus k square minus 8k will be 0, correct? So you will getting a quadratic in k square minus 8k plus 7 is equal to 0. So the value of k will come to be minus of minus 8, that is plus 8, plus minus 8 square, we are applying the quadratic formula, 64 minus 7 into 4, 28 divided by 2. So we'll get what? 8 plus minus root of 36 by 2, that is 8 plus minus 6 by 2, correct? So you will get the value of k as one value will come to be 8 plus 6, that is 14 by 2, another value will come to be 8 minus 6, that is 2 by 2. So the value of k will come to be 7 or 1, okay? Now see, v cannot be equal to u because the motion is accelerated. It cannot be equal to 1 since the k is what? K is v by u. So if k is equal to 1, it will imply that v is equal to u, which is not possible because motion is accelerated, okay? So this is u and this will be v, so both value will be different, they cannot have the same value, correct? So physically possible, so we are rejecting the value of 1, so therefore the value of k will come to be 7, and k we have taken what? V by u, so the answer of the ratio of v and u is what? 7. So this is the answer to second part of the problem, got it? So we got the answer to both parts of the problem. First we have find the relative limit, that is coming to be root of u square plus v square by 2, and second we have to find